quadratic equations in disguise? We did 2 examples, is that right?
Yes, miss.
Yes, okay. So we will discuss one more example, and then we will look at a couple of exam type questions that you get in that too, and then we will start coordinate geometry. Okay, so put example 3. This is under quadratic equations in disguise. Example 3. Is the document too dark? Is the writing pad too dark? Or is it bright enough for you?
Bright enough, miss.
Bright enough, okay. Example 3. Okay. You have solved 2 plus 3 over x is equal to 7 over root x. Now both your x's are in denominators of 2 terms. Right? Now, does this look like a quadratic? Now, what is our topic here? Quadratic equations in disguise. So you can have an equation can come to you, doesn't look like a quadratic, so it's in disguise, so you don't recognize him. So does this look like a quadratic to you? Do you see an x square anywhere? I mean, not anywhere. You have to have your x square on top, not in a denominator even, right? In a quadratic equation, what's the form? Ax squared plus bx plus c equals 0. That's a form. You can't have x square in a denominator. So this doesn't look like a quadratic. So we don't know, it might be, we might be able to turn it into one. So let's try. So what do you think we can do first? In any equation, anyway, when you have fractional terms, you get rid of the fractional terms. Okay. So to get rid, I have a fractional term here and a fractional term here. Here the denominator is x. Here the denominator is root x. I need to multiply the whole equation by something to get rid of that. What should I multiply the whole equation, the 2 sides of the equation by, in order to get rid of the fractional form? So I need to get the x off here and the root x off. I should multiply, if I multiply by what? So I have to choose that thing that I should multiply both sides of the equation by. What should I multiply it by? It's like, if I show you something with numbers, you will understand. If you have 2 plus, if you had your x on top, say x over 3 equals x over 7, something like that. If you had, you would multiply the whole equation by what number? So that both 3 and 7 get cancelled and get removed. 21. You multiply by the common denominator to both 3 and 7. So that's 21. If you multiply the whole 2 sides by 21, you can get rid of that 3 and 7. Same thing here, right? I have x and root x. Senator says root x into that can work too, but there is a lower term that you can multiply this by. It's like for the earlier one, if you tell me multiply both sides by 42, that'll work too, but 21 is the simplest one, smallest common denominator. What's the smallest common denominator for x and root x?
X.
X, because root x is in x. Okay. Neunaka says multiply by x square. That's even bigger. That's even bigger. So think of a number here. If you had 2 and root 2, put a number for x here. If this was 2 and this was root 2, what's the smallest common number for those two? 2 and root 2. 2, yeah. Okay, so like that, you can multiply by x. I mean, if you multiply by x squared, a bigger one than that will still work. You will just have, you know, big expressions. So multiplying by who said first? Senitha first said multiply by x root x. Works, it works, but it's not the smallest one. Neunaka said multiply by x squared would work. You can get rid of the fractions here, but that's not the smallest one. Smallest one is x. Okay, so I'm going to multiply both sides by x. Both sides by x. So here, each term gets multiplied by x. I get 2x plus this times this, the x gets cancelled, 3. There you go. I got rid of the fraction there. And then on this side, how does this simplify? Because x is root x times root x. We learned this in surds. X is made out of root x times root x. So let me write it out for you, just for you to show. This x I can write as root x times root x. So one of the root x's get cancelled. And I have 7 root x on that side. 2x plus 3 equals 7 root x. Now, does it still look like a quadratic to you? Does anyone see a quadratic here? No, right? Okay. Not yet, but you can turn this into a quadratic. Now, do you see anything? Does anyone see anything before I?
7 root x can be written as 7 x root squared.
That's right. This x is actually root x times root x. So that is root x squared, right? Let me write it first. 2. This I can write as, right? And then at the same time, shall I bring this to this side? Because I am expecting this. I'm anticipating to get a quadratic. So let me bring all the terms to one side anyway. And let me put this in the middle. Minus 7 root x plus 3 equals 0. So that I have like the form kind of. Now you do a little relabeling. In these quadratic equations, in this, guys, until you do that relabeling, it won't be quite visible to you that it is a quadratic. Here's my relabeling. You just relabel this. You call root x by something else. Let root x, let's call root x, shall we put t or u, or usual letters that we use are t, u. You can use anything, m. You can even use let's call root x cur. So you will have 2 cur squared minus 7 cur plus 3 is equal to 0. Why do we always take English letters? Can't we take Sinhala letters or Tamil letters? We can. Okay, you should do that in the exam. The examiner will have a good laugh, and I'm sure he will enjoy. But you have to on the side make a note and say, that's, by the way, that symbol is a Sinhalese letter. Sinhala letter, yeah, or something. That's a cool thing to do. Okay, so I'm going to use t. See what this turns into now. This turns into 2. This is t squared minus 70. It sounds like 70. Plus 3 is equal to 0. Now that is a quadratic, right? we have a quadratic equation of t. That's okay. Not x. X is gone. T. Finally, we can bring back the x. So the only reason why we did the relabeling is just so that we get this comfortable. I mean, even here it is a quadratic. You should see it. But with the root x, it's very, I mean, it's blocking, it's confusing your head, right? But now it's very plain and simple. So you can solve it. Can you solve it? There is a 2 in front. You can use a calculator and input ABC. By the way, do you all know how to use the calculator to type in the values of A, B, C and straight away get the answers for the quadratic equation? Do you all know how to do that?
Yes, miss.
Okay, you're sure, right? What I mean is not plugging in the values to the formula. Not plugging in the values to the formula. The calculator already has the built-in formula. So you just give what A is, what B is, and what C is. You just give, and then it gives you the answer. That's what I'm talking about. You all know how to do that.
Yes.
Yeah, right. Okay. So let's save time. And I mean, but if you do the factorizing, that works too. This factorizes. Yeah, mode 5 and then third. Yes, that's correct, Senitu. You go to mode and it's mode 5, equations mode. And then under that, the third type, that's a quadratic. And then you give A, B, and C, and it gives you the 2 answers. So simple. It's allowed for you to do. You can do that. But I don't know. It's your, I will let you, because this is like just O-level work. What are the 2 answers for T you get? So I'm leaving some space for you to fill up. You have the freedom to do in any method, solve it in any method you like, and tell me what the 2 answers are for X, for T. The 2 answers for T.
T is equal to 3 and T is equal to half.
3 and half. Okay. Right? We solved for T. Now you bring back your T is something that we took, right? We used as a label. What is T? T is root x. So bring root x back here. T is nothing but root x. Root x is 3. Root x is half. You have to have an or in the middle. Root x is either 3 or root x is half. Then what is x? How do you find x now? You square both sides. You square both sides. Square, 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 whole thing, square. So x is 9 or x is quarter. There you have your 2 answers for x. Okay. So if I go back, yes?
Miss, if you don't mind, can you just explain it again, just like a summary? I just got confused somewhere.
Yeah, sure. Okay, so here's the first. I'm glad you said that. I want you to say like that. Okay, if you get confused, you might even not know where you got confused. That's fine. So you just need to tell me like that. Please, everyone, remember that. Okay, you have to clear everything out during these sessions and make the best out of it. Okay, so let's go through this again. So here's the equation we had. The first thing that we did was it's something that we do when we have any kind of equation, regardless whether it is quadratic, whatever the equation. When you have fractional terms, you get rid of them. Okay, regardless of what the type of equation is, you get rid of your fractions. So how do you get rid of your fractions? If there are, like, say, three fractional terms, so that you will have 3 denominators, you take the common denominator for for those 3 and multiply everything out by that. Then your fractional fractions will vanish. So that's what we did first. That step had nothing to do with whether we are solving quadratic or whether this is a quadratic in disguise or anything like that. This step that we did here, this step was something that we anyway do to any equation when you solve any equation. So when we did that, we landed on this equation, right? So it has no fractions. Now you take a fresh look at it then. So I have 2x plus 3 equals 7 root x. You have to see that at this point, you have to see that x is the square of root x. If you don't see that, you wouldn't be able to see that this is in fact an equation, quadratic equation in disguise. Okay, so that's crucial here. The ability to see that x is, let me put that in a little bubble here, x is root x square, root x times root x. If you don't see that, you wouldn't say that it's going to be a quadratic. So I wrote my x as root x squared, and then anticipating that I'm going to get a quadratic, I brought all the terms to one side. So that's what I did here. And once you come to this step, now you see that, this is a quadratic in disguise. You identify that in that step, because your square terms. Now, if you look at your earlier examples, go back and check out your second example and the first example. You had the square of something and that something in another term. So you do a relabeling. So for this thing that you have, for this thing here, it can be anything. The point is that the format is you get, so let me write that in a little box here. You will have something squared plus something, then plus a number equals 0. Here you can have some unusual looking thing. Then if you call that whatever the same thing here, whatever something, the same thing here. So you have square of something and then that same thing here. So that means if you call that thing with one letter, say u squared plus u, then it's a quadratic. It turns into a quadratic. That's the whole idea here. So that's why I used the relabeling. I'm calling root x as with one letter, t or m or n or whatever. Then my equation became 2t squared 7 minus 7t plus 3 equals 0, and that is a perfect, beautiful, nice, plain quadratic equation. And I know how to solve that. And I solved it. I got the 2 answers for t. Once you get the 2 answers for your t, which is something that you took, it wasn't there in the original equation, then you replace it back with what the equation had, which is root x. And you solve for that x. And you get your answers for what you had in the original equation, which was x. Clear, Afra? Oops.
Yes, miss, I got confused when we made the quadratic equation. So the fractions normal equation, like the into x root, that one.
Okay. Now, power just went out here, but it's still working because the router I'm using, it works even without power. But so everything is working, right? The only thing is my fan is not working, so I will start to sweat here now. So let's see how far we can do this. Everything else is working fine. The lights are gone, so it might be a little dark now. It came back. Hari. Okay, so I have to put the, that never happened before, right? Can I zip some water also? Take a small break. Can everyone take a small break and zip some water? Or stretch out a bit? Stand from your seats. Look far away, look at something far away. Rest, give a break to your eyes. You've been looking at the screen for a long time. Okay. We should do this every day. I keep that in mind, but I forget because I get, I get immersed in what I do and then I forget to give you a break, but remind me to give you that break. After like 1 hour or like in 45 minutes, we should all take a break. That helps us in our, because otherwise we will be mentally tired. If you take breaks like that, it helps us in your understanding because your mind gets refreshed, right? Okay. Did you all drink some water? Hope you did. Okay, now I'm going to show you. I'm going to give you. So that's all the examples I have. I will send you a homework from the textbook for you to do over the week. But before starting coordinate geometry, I will give you one question from a past paper from this little part, quadratic equations in disguise. Okay, let me see. Yes, Afra?
Did you receive the my address? I sent it to
Yes.
you.
Okay. So this is the latest story about that. Thank you for reminding me that. I was all set to send you these booklets, but then A plus. I was able to contact A plus yesterday, so they are open. They are open, and I will keep all the books. So there are however many. Let me just check how many of you are here today. Because anyway, now I'm actually a bit confused. We used to have Senadi. Senadi is no more with us, right? I think she has discontinued. Do you know Senadi? I used to have a Senadi in the group. Does anyone know Senadi? Is that the right? Is that the right name? Senadi. Do you know Senadi? Yeah. Okay, so no one knows Senadi. So for the 11 of you, if I keep, so I'm going there next week though. Okay, I'm going there next Saturday. So I thought, I mean, our postal service also, right? Who knows? It might take, usually how long does it take, Mr. Chamin De Silva? For when you post something, like a parcel? The Vattala or that area, Mahabagi? A couple of 3 working days. Yeah, okay. And so I thought, let me just, I will keep the books there and then you can collect it from there because you all live around that area, right? So I'll do that. Yeah, okay. Right. So let me quickly, I'm trying to open give me a moment. I'm trying to open the Quadratics booklet. Where is it? Which screen are you on now? I completely lost it now. I don't know which screen you are seeing. You are seeing the document, right? No, I'm not. Okay. We'll do one question. Do you all see the, this is giving me some messages. Do you all see the booklet now on the screen?
Yes, miss.
Yes, okay. Okay, this is the one I want to do, this second question, okay? So can you copy the question? So this is a past paper question directly from Quadratics. As I told you last week, in your exam papers, P1 exam papers, usually you have in P1, P3 mechanics, in all of these modules, you have a question from each topic. That's how it is usually, right? But only for this topic quadratic, because it's not kind of a topic on its own. It has applications in the other topics. So when they make questions, it's very rare that you get a question from quadratics. You get something related to quadratics in other topics, like functions question or coordinate geometry questions and so on. So this question number 2, this one right here, it's 2007 May P1 paper. Can you copy the question and can you try solving it? I'll give you 3-4 minutes. It says find the real roots of the equation. That means solve the equation to find the real solutions. Solve it. And you drop in your answers in the chat box, or you tell me once you get the answers.
This x is equals to 3 halves.
3 halves and it's only that.
The other has no real solution.
Huh?
The other has no real solution.
Oh, so just one real solution, 3.5. 3.5. Let's see. Let's wait for another. Well, let's wait till another one gets the same solution, if that is correct. I think the time should be enough by now. Akitni. Oh, do you get plus or minus 3.5?
Yes, miss.
Okay. Right. Plus or minus 3.5. Now, in this, so what about the others? Can I just have some response from others? Are you all still doing, or I can give you time because I want each one of you.
Still doing, miss.
What's that?
Still doing, miss.
Still doing. Okay, so I will wait. Okay, I want each one of you to get this answer on your own. It doesn't matter how long you spend. What needs to happen is you have to get the solution. Take your time and get the solution. Later, little by little, we can improve our speed.
Miss?
Yes, Afra?
Miss, I get 9/4 and minus 2.
9/4 and minus 2.
Yes, miss. I don't know what's the answer I get.
Okay, right. Okay, let's see. Others, I have to hear from each person. So I'll tell you, can everyone write in the chat box, then I have a record of everyone's solutions, because I forget. When you just tell me, I forget who told me and who hasn't told me. I forget. So Akitmi has written her answers. Like that, can everyone? Okay, thank you, Lishan. Lishan has gotten the same as Afra. So let's see. Others, can you all drop the answer that you got individually? What you got? I don't know the answers yet. I don't know what the correct answer is. Afra has 9/4 or minus 2. Okay. Still only 3 of you have let me know on the chat box. I have to wait. Okay, Tenumi. Akitmi, so can we say plus or minus 3/2? You said 3/2. Oh, you get 3/2 or 3.5. So whether you can say plus or minus 3/2 or just 3/2, it depends on how you got it. Like if you had, it depends on how did you get the plus or minus. If you square rooted something, you will get plus or minus. Then you always get 2 answers if you had to square root. That's how the plus or minus comes into an answer. Okay, so Aisha got plus or minus 3/2, not 3.5, 3/2. Okay. See, this is interesting, right? Y'all are getting different answers. So let's see. So far, Akitmi, Lishan, Afra, Tenumi, Aisha, and Senitu also has. Senitu has 1.5. That is 3/2. He only has just 1.5. So only 6 of you so far. How about, who do we have here? Neunaka, Nesaki, Sandali, Senut. Okay, Nesaki also has plus or minus 3 over 2. Sandali has plus or minus 1.5. Pesandi and Senut. 2 more people, I think, if I didn't miss anyone. And Neunaka. Okay. Okay. Senit also got plus or minus 1.5. Pesandi got plus or minus, that is same as well. Okay, now everyone has responded. So a set of, you got plus or minus, okay, plus or minus 1.5. Some of you got 9 over 4 and minus 2. So let's check this, okay? Let's go ahead and do it. I will do it in the, you can check your work. So let me copy the question to the paper. 18 over x to the power of 4 plus 1 over x squared equals 4. Okay. Right. So again, when you see this equation, before anything comes to your mind, what you have to be thinking is, it has fractions and I should get rid of fractions. Okay. Don't worry about anything else. If you have like fractional terms, the first thing you have to try and do is, let me get rid of these fractions. That's what should work in your mind, the first thing. So you look, there are 2 fractions, 2 fractional terms. So there are 2 denominators. You have to take the common denominator. You have to take the lowest common multiple of these 2. Now, as I said, it's always good to take the lowest, but you can take any higher thing also. Say you have, if you have 4 and 2 in 2 denominators, 4 and 2, the lowest common multiple is 4. Common multiple is 4. If you take 8 and multiply everything by 8, still these would get cancelled. You can get rid of them. Or 16 still would work, but the lowest is 4. So it's easier to work with the smallest number. Just like that, here you have x to the power of 4. You have x to the power of 4 and x to the power of 2. What's the lowest common multiple that they have? X to the power of 4. Now, does anyone have any unclarity in figuring out the lowest common multiple, especially when you have not numbers but these letter things? Okay. Does anyone have any unclarity there? Because I can spend a few minutes, 1 or 2 minutes, and just clear if you have any unclarity in it. No, right? So here, what is the lowest common multiple for x to the power of 4 and x squared? Someone? There is a breeze here. Like, okay, I'm going to go and just close the window. Give me a moment, okay? Let me close the window and come. My paper is flying otherwise. I want to. Right, what's the lowest common multiple of x to the power of 4 and x to the power of 2?
Excuse me, Miss.
Yes, Afra?
Miss, my answer is also plus or minus 1.5 and no real solutions for the other one.
Okay, so it's just plus or minus 1.5, right? Okay, let's see.
Yes.
Now, can someone tell me what's the lowest common multiple of x to the power of 4 and x to the power of 2? Is
X to the power 4.
x to the power of 4. Is that clear to everyone? Right, okay. Now, yeah, so this is the disadvantage in this mode. Like one or two of you might respond, but I don't see the other people's faces. I don't know whether it is crystal clear to everyone. So it's x to the power of 4. So you have to tell me. That's why I'm relying on your response, okay? So the lowest common multiple of these two denominators is x to the power of 4. So I'm going to multiply both sides by x to the power of 4, both sides. Right? When I do that, so each term here gets multiplied by x to the power of 4. So I get 18 here. Plus, when I multiply by this, I get x squared there. And here I get 4x to the power of 4. Right? Now I have gotten rid of the denominators. It's a plain line equation. Now you have to see there is an embedded quadratic here. A quadratic is embedded here. It's a quadratic in disguise. How do you see that? If you can see that x to the power of 4 is in fact the square of x squared, the same thing here. You should see, this is square of something I have, and then that same thing is here. So this can be turned into a quadratic. So let me first write them on the same side. I'm going to take these two terms to that side, but then I'm going to write all of them here. So this is 4 x squared squared minus x squared minus 18 equals 0. Now I will do that little relabeling. I'm going to label this whole thing with a single letter. So I say let me call x square with a simple, I'm using the 3 lines to say just a relabeling, okay? I'm just going to call that by a single letter. I'm going to use m. So my equation turns into 4m squared minus m minus 18 equals 0. I have a very plain quadratic equation. That is my quadratic equation. So I have turned my equation into a quadratic equation, right? From this, at this point, you can just use the calculator, but let me try, does this factorize? Minus 18 times 4. What is minus 18 times 4? Did anyone actually like do the factorizing?
Minus 72.
Minus 32. Can I take
72.
It's 72.
72.
and of course 18 times 4, 72. My 72, right? So I have to get minus 1. I can do minus 9 and plus 8, isn't it? So let me just do that. 4m squared minus, let me put the 8 here so that I can take it with the common 4, minus 8, sorry, that's plus 8m minus 9m minus 18 equals 0. Take 4m out, m plus 2, I take a minus 9 out, m plus 2. So I take m plus 2 out, and then 4m minus 9 I get here. I can see now, those who gave me, I get m is minus 2, or m is 9 over 4. Now I'm straight away, I'm not even showing you that step where I say m plus 2 is equal to 0 or 4m minus 9 is equal to 0, because we are in advanced level now, right? You can skip that step because you can see what the two solutions are. Now there are the people who had given me these two answers. These are not the answers. These are the values of m. Who said to solve for m? I didn't even have an m in my original equation. I have to find what x is equal to. So don't ever forget to bring back your x. So what did you call as m? X squared. So this is actually x squared is equal to minus 20, because you have to solve for x, or x squared equals 9 over 4. X squared is equal to minus 2. If I square root, nope, no real solutions. I don't get anything there. So if I square root this, I get x is equal to plus or minus, that is 3 over 2. So that is correct. So you get two answers. Okay. So that's good. Many of you got the right answer. Very nice. Okay. I think I have a small issue. We have only a little amount of time left. But I think we will start coordinate geometry. We'll take an introduction to it. Okay. So we have come to the end of quadratics. I want you to quickly take maybe 1 minute. You have your notes. Go back and like turn the pages. Go through everything, and let me know if you have any unclear places in this chapter before we put it behind us and move to the next chapter. Take a minute to quickly go through everything and make sure that you have understood everything. Take 1 minute and check your notes. If I tell you the main topics in quadratics, you should know what a quadratic expression is. You should know the three different forms in which a quadratic expression can be written: standard form, complete square form, and the factorized form. And we learned about the quadratic function and its graph, features of the quadratic function graph. We learned how we can sketch the graph when the quadratic function is given. Then we learned how to solve quadratic equations. We learned how to solve quadratic inequalities. That method involved partly an algebraic steps, and then mainly a visual or a graphical approach in solving a quadratic inequality. And then finally, quadratic equations in disguise. Aisha. I have a doubt in completing square method. When we enter minus 3 squared without any brackets, we get minus 9. But when you apply brackets, of course, and that is not what completing square method is. Okay, this is good. I can see that you are dropping your questions. Let me address first. Let me address Aisha's. First of all, Aisha, I get your question, but the way you started your question, why did you bring in completing square method? That has nothing to do with the completing square method. You're asking why it is in the calculator, if you just enter minus 3 square Even not in even the calculator. If you ask me to simplify this, if you write something like this, just minus 3 squared, answer is minus 9. Why? Because this minus, I mean, you didn't tell me. If you tell me this, that is 9. Of course. Do you not see why? What this means is, you didn't use a bracket to tell me that include the minus into the squaring. Without the bracket, what everybody would understand is this square belongs to only the 3. So that is 9, and then the minus would stay outside as it is. So it's minus 9. So by not including a bracket here to include the minus 3, you are telling me what this actually is this. That's what it means. When you just have minus 3 squared, what it means is this. So that is minus 9. Okay. If you have the whole minus 3 squared, it means minus 3 times minus 3. That is 9. Clear?
Yes, miss.
Okay. Then Senithu's question, b squared minus 4ac, the discriminant, does it give 2 x coordinates in a graphical representation if b squared minus 2ac is greater than 0? Okay, so 2 things about this discriminant, okay? First, if you are talking about, say you're talking about a quadratic equation. Say I give you a quadratic equation. No, let's take a quadratic. X squared plus 4x minus 3 or something like that. That's just a quadratic. No? That's just a quadratic. Here's a quadratic equation. X squared plus 4x minus 3 equals 0. This is the expression. This is the Q expression. Here's the Q equation. Here's the corresponding Q function, quadratic function. Right? Using the same quadratic, I can have an equation in which I have that expression. I can have a function in which I have that expression. I can have an inequality with that expression. What do I do with each of these? What do I do with if I just have the expression? Nothing. There's nothing you can do to this. Somebody can ask you to change its form. That's all you can do. Maybe change its form, maybe simplify it further if possible. That's all. What can someone ask you to do with the equation? They can ask you to solve it. What can someone ask you to do with the function? They can maybe ask you to graph the function. That's one possibility. Or they can ask certain other questions. They can ask you to find f of 2. Things like that. What can you do with this? You can be asked to solve it. Now, what does the discriminant have to do with any of that? Okay. Now, all of these, we can talk about the discriminant of this, discriminant here, the discriminant here, the discriminant here. Isn't it? What this discriminant tells you, depending on the sign of the discriminant or whether it is 0, one thing you can, if you are talking about the equation, I will tell you everything that you can talk about using the discriminant. In the case of the equation, by checking the discriminant, you can say whether your equation is going to have 2 solutions, 1 solution, or no solutions. If the discriminant, I'm talking about the case of the equation. If the discriminant of this expression in the equation is greater than 0, you will have 2 solutions. If the discriminant of this expression is equal to 0, it will have 1 solution. Repeated same solution, that means 1 solution. If the discriminant of this expression in the equation is negative, this equation will not have any real solutions. If you are talking about the function, now let's come to this. how does the discriminant help me to say certain things about the function? If I'm talking about the function, I can say if the discriminant of this expression is greater than 0, if it is positive, that means the graph of this function will cut the x-axis at 2 points. And those 2 points are the 2 solutions of this equation. Because the equation is when I equal this to 0, equaling this function to 0 means I'm looking where it's cutting the x-axis. On the x-axis, y is 0. Okay. And for this function, if the discriminant is equal to 0, that means the graph of the function, the parabola, is barely touching the x-axis at 1 point. And that 1 point is the solution of that equation also. And if the discriminant is negative, the graph of this function, the parabola, is not touching or cutting. I mean, it's not nowhere near the, it's not, I can't say nowhere near, it can be near to the x-axis, but it doesn't touch it or cross it. Okay, so this discriminant, using the discriminant, you can talk about the solutions of the equation. You can talk about the graph of the function. Different things you can talk about because it's the same expression that appears in the equation and the function. And also, when you have a pair of simultaneous equations, when you combine them into one quadratic, the discriminant of that quadratic will tell you whether how many answers you are going to get. These are the usages of applications of the discriminant. Did I answer your question, Senetu? Senetu, were you listening, or are you have you fallen asleep? Senetu, are you there? Senetu? Now, Senetu is the one who asked this question. The solutions, do they represent the x-coordinates of the graph? Yes, yes, they are. Say this is your y equal. I mean, this will be wrong. I'm just sketching. Okay. Sorry, x squared plus 4x minus 3. Then at these 2 points, what can you say about this expression? It's equal to 0, isn't it? At this point, x squared minus 4x plus 3 is equal to 0, isn't it? So that's the that value there of the x, which is x-axis. For that value of x, the value of y is 0. So that is the solution for that equation. That's correct. The solutions represent the x-coordinates of the graph. Yes, they are at the points of x-intercepts. This is a huge thing that we are discussing. I doubt whether you have fully, completely understood that. So take your time. You're welcome, Senator. So for Afra is asking, for equations in disguise, do they have a curve-shaped graph? So nicely phrased question, because you're asking, do they, because there are 2 equations, do they have a curve-shaped graph? It depends on the type of equation you have. So in your simultaneous equations, if you have a linear equation, like for example, let me take you to, do I still have it open here? Yeah, I do. Let me take you to the set of equations we solved for homework. So for example, if you check these 2, okay, this first equation, you still don't know these things. This first equation, if you graph this, if you take different values for x and y and graph this first equation represents a circle. It has x squared and also y squared. This is a circle. This equation, it's a straight line. any linear equation of x and y is a straight line. Here, this again, this in the second one again, this represents a circle. This is a line. Let me show you. For example, this one in the 11th pair. This first equation, you have x square only in x. So that's a parabola. This first equation represents, if you graph it, it's a parabola. This is a straight line. So graphically, now this is exactly what you learn in coordinate geometry. The next topic we are starting. In coordinate geometry, you are going to see the connection between what you do in algebra, like solving equations, how that can be visualized using a graph. So solving this pair of simultaneous equations, which is a purely algebraic process. Do you ever think of a graph when you do this? No, you just algebraically, you multiply, you add, and you are manipulating these symbols until you get your x and y. But that process that you do algebraically has a geometric meaning, has a visual meaning, because each of these equations represents something geometrically. As I said, this first equation represents a parabola. The second equation represents a line. And solving these two equations simultaneously algebraically graphically means to see where the parabola and that line cuts. Okay, so for your question, now Senitu is also asking, in the term polynomials, what does nomial mean? Nomial means terms. Poly means many. Now, I'm sure poly is a little thing that you have seen in other places. Polyester, polymer, polysaccharide. I don't know whether you have, like in chemistry, you see these other words that start with poly. Poly means many. Nomial means, nomial is term. Nomials is terms. So polynomial means many terms. Many terms, an expression with many terms, but it has a better, more precise definition, but that's the meaning of the word. Okay, Sanitha? You can't call a cubic equation a polynomial. Equation is an equation, but in any equation you do have, now now this is something very important. Cubic expression, yeah, it's a polynomial. Now, wait. Now, if you have x cubed minus 3x plus 4 is equal to 8x plus 2 or something, this is a cubic equation. Why do I call it a cubic equation? The highest power of x is 3 here, so it's a cubic equation. Remember, an equation has two expressions equated. It has two expressions. Here's one expression, and here's your other expression. This expression is a cubic. Yes, it's a polynomial. It's a cubic polynomial. This expression on the other side is a linear polynomial. Okay? An equation always have two expressions on either side. Afra. So if we plot the final answers of a nonlinear simultaneous equations, we don't get a parabola. If you plot the final answers, what do you mean by that?
Final values of x and y.
Yeah, those represent just 2 points. So wait, for example, I will okay. Let's think about this 11th question. Okay, this 11th question. What were our answers? Do I have my answers here? I can't find the answers, but anyway, as I said, one equation represents a parabola. The other equation represents a line. This is a parabola, this is a line. If I graph them on the same grade, I don't know, depending on, so it could be a parabola and a line like that, where the line is cutting the parabola. The two solutions you got were the coordinates of these 2 points. You got x is something and y is something. Those were the coordinates. Do I have my solutions? I can't remember the solutions now. If you have it, you can just check. I have it here. 11th one, minus 116. You had minus 116, that's 1. The other one is 2, 0. 2, 0. My placement of the points is horrible, terrible. This should be here. And, no, correct. Correct. Minus 116. But it's wrong. This point must be up. This point must be, just get the idea I'm trying to give you here. This parabola represents one of your equations, the quadratic one. This line represents your linear equation. And solving them simultaneously graphically means to find the coordinates of the intersecting points. This is exactly what the whole of coordinate geometry is all about. So if you plot the answers, the two answers are just 2 points now. The two answers are 2 points. And what's the significance of those 2 points? Those 2 points are the intersection points of the 2 graphs that the 2 equations represent. So if you don't get any solutions, that means the 2 curves or the lines or whatever, they don't intersect. Did you understand? Okay, you're welcome. Now, this will sink in with time. Give yourself some time. You won't completely comprehend it like in one go. As you see more examples, when you do more questions, when you learn more theory about, especially when we start coordinate geometry, this will start to really, really sink in, and you will completely understand the whole idea. Okay? So if you feel like you still don't have the complete grasp of what I'm saying here, it's fine. Okay? So I thought before that the 2 intersecting points before form a new, how can 2 points form a graph? It's just 2 points. Right. Yes, good. So unfortunately, not unfortunately, it's unfortunate that we can't start the new topic, but that's fine. I'm glad that we had this nice, fruitful discussion about all your doubts. So it's okay. We will start coordinate geometry next time on a fresh day. We will wind this up now. So just let your mind think about anything in mathematics, especially related to our topics, then it's easy. So think about everything that we learn about when you have nothing like special to do, if you're just sitting and sipping your tea or coffee, you just think about what you learned in this. It's nice if you can. This is how this is how new things we discover new things in math or in any field for that matter. Like you just let your mind wander and ask questions like what if questions in that thing that we learn. What if this happens? Think about things like that. Okay, and to entertain all things like that. Okay, so we'll wind this up. I will send you a little homework